So looking at this screen right now, we can see the traffic light. We can see that there is counting and that there is the reset button. Now, let's just imagine for a moment that this demo box is not right next to me, but it's actually somewhere much further away. In fact, it's at the other side of the world. And to make matters worse, it's a different time of day, so there is no one there that can access it. And I don't have access to Unity Pro, the operator screen, so I definitely can't manipulate the program anymore, because that's well past the development phase, and this was a program that was acquired as part of the PLC, and this is the situation that we face. So trying to access the PLC and to interface with the programmed logic and to affect its control has to be done using an interface, and the interface that we have is a SCADA interface. Supervisory Control and Data Acquisition, that's what it stands for. All we have to do to stop the process from the other side of the world is press this button. And the entire process is halted. The counter is set to 0. And we have established, as the name states, supervisory control. What about the data acquisition? That's also a very important part. Now, for this particular traffic light, I've decided that at 20 total sequences, at the end of 20 sequences, it's time for the traffic light to be halted. Or once it's past 20 sequences, it has to be halted, and perhaps the components have to be maintained. Perhaps previous data suggests, or perhaps we even need data to find out if we are approaching its mean time to failure, is failure imminent, is the reliability questionable. So I need information, and this SCADA interface allows me to plot that information and to monitor it historically. So right here I have selected a color, a pen if you will. I've selected a trend pen, and this trend pen is allocated to the count value of the demo box. And what just happened is, now that I've allocated that, and you can see that the value will be increasing over time, the plot has changed its scale. So we shall change it back to say 100. Select the current trend pen, and we'll change the 0 scale to 0 as well. Current trend pen, and there we go. We can see a historical display of the trend, how it was reset, when, and how many counts. All the information is there, which is very important, because when we supervise a process, especially if the process is controlled by a PLC and it is an autonomous process, it's very important to collect data to ensure that the process is doing what is intended, what it was made to do during development. And there is no real way to confirm that other than to supervise. But with a very simple PLC program, it is easy to say yes, but as the program becomes more complicated, if there are more modules, if there are more processes, and as we already have seen, a program can be very complex. It can be very much capable of doing more than just operating a traffic light, depending on the process it is designed for, then it is very important for there to be an interface that allows for control, that allows for data acquisition in a supervisory sense. And having PLCs that are able to communicate through Ethernet, Internet, makes this supervisory element more realistic. It also makes it invaluable. In fact, it is a certain necessity as the complexity of the program logic increases and the task becomes more complicated.